if you really tried the homework question number 2, it may have given you some concerns or questions. I can tell that most of you tried it, which is great. Can we talk a little bit about how to actually get this graph without Desmos? Okay, again, without Desmos. First off, just getting the features, there's no whole because there's nothing in the numerator denominator that looks the same, but you do get a plus or minus 3 for your vertical asymptote. It's important that you get both of those. Remember, vertical asymptotes divide a graph. So already we should be like, whoa, we're going to be dividing this graph into a couple different, actually 3 different sections. Now the horizontal asymptote, some kids have still been asking, it's all about the degree. The degree of the numerator is 1. The degree of the denominator is 2. So the top is smaller than the bottom. That's y equals 0. And then if you plug in a 0, you get 0. So we end up with an intercept at double 0. Okay, now, even if you did get this, or maybe you kind of guessed or you just aren't sure, let's talk real quick here. How do I know that the graph is down here? Well, you got to plug in an x value that's over on this side. May I suggest x equals -4. If you plug that in very carefully, you get a -4/7. That means the graph is down in the negative place. I can do the same thing over here. I can plug in like 4. If I plug in 4, I get a +4/7. So the graph is actually up here. I saw a few of you had it backwards. So just double check. You have to very carefully plug in 4 and you end up with positive number. This graph in the middle can be a little mischievous. It does different things. We've seen this graph in the middle look more like a parabola. We've also seen this graph in the middle look kind of like it's drawn here. How do we know? You have to continue to plug numbers in. What number? It has to be a number on this side, like maybe -1. If you plug in -1 very carefully, you get -1 over -8. That's actually +1/8. That's why the graph is up in a positive place. But when I plug in +1, I get a negative number. So that's why the graph is down in a negative place. The only way to connect the dots is to do that little S curve. It's not an easy problem, but did you try it, or is this helpful in trying to explain why it looks like this? Is there anything else? Is there something with question 4? It's kind of a little review question. The practice paper you got on your way in is intended to just get you back in the mood. And then again, we want to do a mini check. But can I go over one with you? I'd like to do the first problem on the half sheet of paper. It's actually got kind of a little surprise that we didn't see yesterday. So I thought it'd be good if we do it together. Okay, so x squared minus 16, x plus 5. It's that first problem on your half sheet. Okay, remember, without Desmos, we still have all these tools. And, you know, one of the tools is to look at this fraction. Now, remember, it takes recognizing that you can factor it. As I often say, if you can factor it, you should. It's just good advice. I don't know what's going to happen if we factor it, but let's at least factor it so we have that available. It turns out really nothing happens. In other words, there's not a hole in the graph. That's all right. At least we know that the numerator and denominator look different. But we can kind of move on to the vertical asymptote. The vertical asymptote is still the denominator. It doesn't matter which one you look at, they're both the same. So -5 is the bad number. As we continue to the horizontal asymptote, I want to remind you that it's better to look at we'll call it the standard version. The standard version is when it's multiplied out. When it's multiplied out, I can see the degree. Actually, I can see that the degree in the top is 1 greater. We haven't seen that for a little while, but that means that there's no horizontal asymptote. It actually means, though, since it's exactly 1 greater, you see where we're going here? The top is exactly 1 greater. That's the slant asymptote. Let's find a slant. Again, we haven't done that in a little while, you have to do division. It's really dividing by x plus 5. That means x plus 5 goes on the outside of that little division bar. Okay, now when you put x squared minus 16 in here, you should feel like that there's like a missing x. So we should put that in as a placeholder. Put in 0x. Again, placeholder. All you got to do to divide is look at the first, I like to say like the first terms, look at these first x's and notice that you would have to multiply by x. That's actually what you do. You multiply so you can get x squared. You have to get the same thing. You also get 5x. Of course, I put that underneath 0x. Here's the step. Be careful. You subtract. As I like to teach, though, that means you change the sign. So it's 0x negative 5x, which is negative 5x. Now, that's a really important number because, well, if you're into like little shortcuts, all I got to do is look at that negative 5x and write down one more negative 5 up here. That's the last number I really need to write down because that is your equation. That is y equals mx plus b. Okay, you don't need to continue dividing. You're just going to get a remainder. Like I said, if you're comfortable and you recognize, you're done. As soon as you get mx plus b, or in this case, x minus 5. That's going to be your slanted line. Can we talk more about that division? Is there something to say again? Okay, that makes for some fun when it's time to graph this. Depends on your definition of fun, of course. Let's do the y-intercept. Plug a 0 into the equation. When you plug a 0 into the equation, I would probably plug it back into the original form because it quickly can give you negative 16 over 5. Negative 16 over 5, it's not like the nicest thing, but it is the y-intercept. By the way, you should have a little idea of the value of negative 16 over 5. You know, I'm talking about like what number that's really close to. It's really close to negative 3, okay, because it's almost 15 divided by 5, but it's 16 divided by, so it's really close to negative 3. That'll be helpful when we have to do a little bit of graphing in a second. How about the x-intercept? The x-intercept is when the numerator is equal to 0, as long as there's no other numbers floating around. Well, thank goodness we factored it because it's easy to see that negative 4 and 4 are those numbers. Now be careful. Did negative 4 or 4, did it get taken or stolen by something else? No. That means that we can use it for the x-intercepts. But if negative 4 or 4 had been a hole in the graph or some other number, then it's not going to be an x-intercept also. Of course, for this problem, it is. Okay. We're doing this together, but are you still thinking a little bit or a lot? You can do the same stuff we've done many times. You can graph these features. You should do this. Also, you should trust what you found. You should trust that you found a slanted line at y equals x minus 5. You know, it's got a slope of 1 and it's got a y-intercept of negative 5. So graph it like that. You know how to graph negative 5 as a y-intercept. You know how to graph a slanted line. So get this thing prepped and ready. These intercepts are actually really important because they will provide for us points that we can connect. So when you plot these points, like negative 4, put it in the right place. Negative 4 has to be in that little spot. Now, positive 4, I'm graphing the x-intercepts for some reason. Positive 4, be careful. If you think about a slanted line, positive 4 would end up on this side of that line because of the slope being 1, etc. So we end up with squeezing that 4, 0 right there. And then we talked about the y-intercept. The y-intercept, remember we said it's really close to negative 3, so it would have to be up there. Make sure you put these points where they make sense. Now, that's a lot of points all in one place, but what that does is helps us to see that the graph, and now you've seen a graph like this before, the graph is going to have to connect or go through those points. There has to be a little bit of experience that tells you that if the graph's going to go through those points, as it continues, it's going to approach the vertical asymptote. And then how about over here to the right, as it continues, it's going to approach the slant asymptote. That's not easy. We didn't do that yet, but I'm here trying to say that what else could it do? It has to go through the points and approach the asymptotes. Now, over here on the left side, there has to be something in you stirs that says there's a graph over here. Okay, so we can't ignore. We have to try to think about a graph over here. Can I tell you that this graph here, or I should say this branch here, is a possibility, but it's not right. Although I do want you to realize it's a possibility. Okay, first of all, it's a possibility because it is interacting with the asymptotes, but it's not right because of that. Look what you did. Look what you did. You made another x-intercept. Okay, so it can't be that branch. The other possibility would be the branch that's a little bit more down in this wedge. Okay, and that's the one that it has to be. Now, that's the one it has to be because it can't be the other one, or because you decide to investigate a point. Now, this takes a little bit more, work, but if you decide to investigate a point, like maybe -6, it's not terrible to plug -6 into this equation. It is maybe not necessary, but I want to show that if you plug in -6, you do end up with a conclusion that is helpful. Okay, you get 20 over -1, which is -20. Well, folks, -20 is going to be way down here. So that gives you another kind of reason to draw the branch in that spot. Slant asymptote. I wanted you to see one. I also gave you a few more to practice on here. Now, there's 3 problems. Maybe you'll have enough time. I don't want you to stress out, though, if you don't get to all 3 of them before the mini check. If you get to 2 of them, that's probably fine. But I did give you the 3rd one to continue to try to help you.